Welcome to Advanced Learning Tutoring. This is the physics playlist. Please like this video and subscribe to our channel. Space physics, our solar system. Within our solar system, there is one star, the Sun, plus the 8 planets and the dwarf planets that orbit around the Sun. Natural satellites are the moons that orbit planets, are also part of the solar system. Our solar system is a small part of the Milky Way galaxy. The Sun was formed from a cloud of dust and gas, known as a nebula, pulled together by gravitational attraction. In the Sun, or in stars, we have the process of nuclear fusion. Fusion is the joining together of 2 atomic nuclei to form a larger nuclei. An example in our Sun would be the joining of 2 hydrogen nuclei to form a larger helium nuclei. The life cycle of a star. A star is formed by a cloud of gas and dust, known as a nebula, colliding due to gravitational attraction. This then forms a protostar and then a main sequence star. From this point, depending on the size of the star, we'll have 2 different life cycles. Stars that are about the same size as the Sun will then form a red giant, a white dwarf, and then a black dwarf. This is all due to the size of the forces acting outwards and the size of forces acting inwards on the star. When these forces are balanced, the star will remain as it is. As soon as these forces become unbalanced, the collapse of a star begins. For those stars that are much bigger than the Sun, following on from a main sequence star, it forms a red supergiant, and then a supernova, which is an explosion of a massive star, forming then either a neutron star or a black hole. Fusion is the processes in stars that produce all of the naturally occurring elements through our solar system. Elements heavier than iron are produced and scattered in a supernova. A supernova will distribute the elements through the universe. Orbital motion, natural and artificial satellites. Gravity provides the force that allows planets and satellites to maintain their circular orbits. For circular orbits, the force of gravity can lead to changing velocity but unchanged speed. We recall that velocity is speed in a given direction. Therefore, as direction changes, velocity changes. For a stable orbit, the radius must change if the speed changes. To explain why the velocity of a satellite changes as it orbits the Earth, we consider the force of gravity. Gravity causes the satellite to accelerate towards the Earth. The acceleration causes a change in direction. Therefore, velocity changes because direction changes. Note this does not necessarily change the speed, just direction. Redshift. There is an observed increase in the wavelength of light from most distant galaxies. Recall from the electromagnetic spectrum and the visible light range that red light has the longest wavelength and violet light has the shortest wavelength. The further away the galaxies, the faster they are moving and the bigger the observed increase in wavelength. This effect is called redshift. The observed redshift provides evidence that space itself, or that the universe, is expanding and supports the Big Bang theory. The Big Bang Theory suggests that the universe began from a very small region that was extremely hot and dense. The prediction from the Big Bang Theory of more distant galaxies should move away faster has evidence provided that more distant galaxies have a greater red shift. Another prediction from the Big Bang Theory is that the initial Big Bang heat should now be thinly spread across the whole universe. The evidence that proves this is that cosmic microwave background radiation is ever at a temperature of about minus 270 degrees Celsius. Astronomers see redshift in virtually all galaxies. It is a result of the space between the Earth and the galaxies expanding. This expansion stretches out the light waves during their journey to us on Earth, shifting them towards the red end of the spectrum. The more redshifted the light from a galaxy is, the faster the galaxy is moving away from Earth. Since 1998, astronomical observations of supernova have suggested that distant galaxies are moving away increasingly faster. The expansion of the universe appears to be accelerating. Scientists do not entirely understand how this could happen, but they have come up with an idea called dark energy. The nature of dark energy is still a complete mystery, but it is thought to cause the universe to expand faster all the time. Astronomers have calculated that to make the universe accelerate as observed, dark energy must account for 68% of the universe. Another recently discovered anomaly is that galaxies seem to rotate too quickly for the mass of their stars. This suggests that there is a mass in the universe that is invisible to the instruments used by scientists. Scientists only know that it is there because it has a gravity that affects nearby objects. This unknown material has been called dark matter. Astronomers have calculated that 27% of the universe must be made of this dark matter. There is much about the universe that is not understood, for example, dark energy and dark matter. Only 5% of the universe is made of the matter, stars, galaxies, people, planets, and so on, that is currently understood.